Good morning, everyone. Hopefully, you are aware that this is about Python 3 on mobile devices and not the C++ session. Yeah, this is Thomas Perl, and yeah, he will do that. Good morning.
Okay, good morning, everybody. My name is Thomas Perl. I work with Yola, and in the next hour, I guess, we'll be seeing how you can combine Python 3 and Qt 5 with QML, and why you want to do that, especially on mobile devices. Okay, so will just be some background, how it came to be that I would want to do Python applications on mobile devices, comparing with existing solutions or with, like, if you want competitors, so other libraries that allow you to use Python with Qt. A short overview of what the API looks like, but we will go more in depth on that later. What it currently supports, some status, and what it might support in the future. And then we'll do some live demos. Okay, so it started in 2007. Back then I was still using GTK, but also with Python. And it turned out that there were some mobile devices coming out, which you could use. And it was running desktop Linux. The MIMO devices, some of you might know. And there you could basically take your GTK application from the desktop and run it on mobile. You could do some, you obviously have to do some modifications to the UI, but basically it just works and you can port forward and backward between the desktop and mobile, which is kind of fun and nice. Then 2 years later, the N900 came out, which was a Linux-based phone. Again, using mostly desktop Linux stuff. And again, there still GTK was used. You could also use Qt there already. But basically, the main UI toolkit that you use there is GTK with some modifications to fit the mobile use case a bit better. That was called Hilden. Again, 2 years later, the N9 came out, which was the first and last MeeGo phone. And it used actually Qt 4 for its native UI and QML. And there were the Python bindings that are called PySide, which I'll discuss about that a bit later anyway. And basically, still, you could do Python applications on mobile, this time with Qt, and you used PySide to communicate between the Python world and the Qt world. And now, it's 2013, and Sailfish is coming, and we obviously want to have something to allow us to do Python development together with Qt again. And this is where PyUGAT comes in. And obviously, because I've been doing this for some years now, I have some ideas about what is bad. So some UIs that I did and some applications that I did, they were kind of lagging on mobile devices. And I'll tell you about why that was and how we can avoid that with PyUGAT. Obviously, you couldn't only do this on MIMO, MeeGo, and so on. There's also other platforms where I could do Python development. There's the scripting layer for Android, SL4A. The scripting layer for Android is a framework where you can have multiple scripting languages. It's not only Python, and you can then use these scripting languages to throw up dialog boxes on your Android device. But as far as I know, there are no real big applications that are using that, especially because even though you can do dialogs and progress bars, stuff like that, you can't do really complete UI on your mobile device. And there are some other things like Pi60 and BlackBerry Tart is very similar project, but targeted on towards BlackBerry 10. So you can it tries to make it very easy to do Python development with BlackBerry 10, but doesn't take care of the cross-platform story. So basically, there are a few options if you want to go with Qt and Python. There's PyQt, which has been around for a long time. It's available under the GPL license. So if you're doing open source application development, and with that I mean GPL compatible open source application development, you can use the GPL version of PyQt. If you do proprietary application development or open source application development with some modules that are incompatible with the GPL, you would have to use commercial bindings there. So you would have to purchase a license for PyQt and use it. On the other hand, it does have support for Qt 4 and for Qt 5, and it does have support for Python 2 and Python 3. Then there is PySide. PySide came out of the motivation to have LG-built bindings for doing Qt development. So basically, PySide does mostly the same things that PyQt does, but it has a different license, which allows you to use PySide without buying a commercial license and do closed source application development for that. And also with PySide, the generator application, so basically the tool that generates the Python bindings for some Qt libraries is also open source, so you can use that to create Python bindings for your own Qt libraries. And the problem with PySide is that right now it only supports Qt 4, so there's no support for Qt 5 with PySide at the moment. It's not impossible, it's just that someone would have to sit down and do that, and nobody so far has stepped up to do that. And on the other hand, it also supports Python 2 and Python 3 already. So if you want to use Qt 4 with Python 3, PySide is also an option. And of course, then there's PyUGAT, which is my project. So I'm obviously biased in some way. But it has a very liberal license. It has a ISC or BSD-like license. And it's just a QML plugin. So it's not a full set of bindings for your for all of the features that Qt has. It's just a QML plugin. It does support Qt 5. There is some Qt 4 support available in the Git history, but because you might not want to start a new project with Qt 4 and you probably haven't used PyUGAT yet in your existing projects, I guess it's a good thing to already start with Qt 5. There is Qt support available. If you want to have it, you can check it out from the Git history, but basically it's not something that I want to concentrate on. But if somebody wants to do it, they're free to do it. And in terms of supported versions on the Python side, it again focuses on Python 3. There's support for Python 2, but it's unsupported and it will eventually go away, just because it's not easy to maintain, and there are some things in Python 2, for example, Unicode strings. So if you're doing strings in Python 2, they are not really Unicode strings, but they're just byte strings, and you have to encode and decode them. And if you mix and match different strings with different encodings, there are lots of problems. If you're doing string slicing on a byte string and you end up slicing in the middle of, for example, UTF character, so UTF-8 character, so basically if you slice it there, then this character basically breaks. So it's not very nice, and these things are fixed in Python 3. And yeah, I think Python 3 is a cleaner language. So because Python 3, for those of you who don't know, Python 3 is a new version of Python that breaks backwards compatibility. So it cleans up some of the mistakes that historically happened in Python, and it tries to clean up the language, because you can't do that in Python 2 because it has to be compatible with all the versions. So let's move on to performance. Obviously, because I'm doing mobile applications, I want to have a really fast application. And the basic idea is, okay, if you do C++, it will be fast. If you do Python, it will be slow. That's obviously not the case, because you can write obviously very, very slow C++ code. You can write quite fast Python code. It mostly depends on your algorithms. But still, what Python brings, it does take more memory. It has a slower startup time because the interpreter has to be initialized. And so what we want to optimize here is the startup speed. So when you tap on the button on your application grid, to the time the first screen shows up, because that's the time where the user sits and waits, and you want to make that as small as possible. With PySide and PyQt, how this happens is you basically write a Python application, and you start that Python script using the Python interpreter. So CPython starts up. CPython is the C implementation, the default implementation of Python. So if you don't know about the different implementations that Python has, CPython can be seen as the Python because it's the default implementation. So CPython starts up, you wait a bit, then it parses your Python code. So you do stuff like from PySide import Qt core, from PySide import Qt GUI, import Qt declarative. So there's already Python code running, and there's still no UI up on the screen. So then the Python bindings are imported, which means that shared libraries are loaded, and the PySide bindings basically have shared library dependencies on the Qt libraries, obviously. So the dynamic linker then works and links up all the symbols, even the ones you don't use in your application, because obviously the Python bindings have to resolve all the symbols in the library. And after the bindings are started up, you basically create a GUI application and do stuff with Qt. So then again, only at that point, Qt starts up, you show your view, and at some point then the user might already be bored. I mean, it's not that problematic, but it is kind of problematic. On the other hand, what we do with Python other side, because it is a QML plugin, for the startup, you really don't need any Python stuff at all. You can, if you make it, if you structure your code in that way that, for example, you have one page that only gets dynamically loaded from QML as soon as the UI is up, there is basically no difference in startup speed between a QML application or a C++ QML application and a PyUGAT application, because it basically, there's no Python code running at that point. Then you see the screen, you can show your logo or anything, you can have a loading animation, and at that point you can start initializing the Python environment. You don't have to do, you don't have to import the bindings, so it's still quite faster, and the nice thing is the first visible screen is up earlier. What about responsiveness? So if you do PySide or PyQt, basically they're the same thing technically. I mean they're different projects and different code bases, but the general idea is the same. It's synchronous by default. That means if you start writing an application and your QML code calls down to Python, which is probably what you want to do, otherwise there's no point in doing QML with Python. So whenever you call down from QML to Python, synchronous by default means that QML will wait for the reply. So your QML engine will wait for the reply. And if it happens that your Python code is slow, or there might be some other thread running Python code, because there's a global interpreter log in Python, it means that it might be that your UI locks up, even for a short amount of time, even if you're doing multi-threading, because of the global interpreter log, which I can explain later more if you're interested and don't know what the global interpreter log is all about, then it still blocks UI. So that's bad. So even if the UI has started up, if you press a button or something, what happens is UI freezes, Python does something, and then UI continues to do UI rendering again. And with PyUGAT, the idea was that I wanted to avoid having slow-looking application or slow-feeling applications. So I designed the API in such a way that everything is asynchronous by default. You can do asynchronous, but I try to make it really hard for you to do so, because you really don't want to do that. And you will see that later on in the API as well. Asynchronous means instead of waiting for the reply, you basically give a JavaScript function or any callable to the function call, and then in another thread, Python will process this stuff while your UI is still continuing to run. And after the processing is finished, your JavaScript callback will be called, and you can do something there. And once you get used to it, it's quite nice. And if you're coming from web development, that's usually very natural anyway. Okay, so another important thing with mobile is library size. That means how much space is used on your disk or on your flash, and how much space is used at runtime, memory footprint at runtime. If you're using PySide, of course it also applies for PyQt. What you usually have is for every Qt module, you have a separate Python module, and that basically connects all the symbols in that Qt module with their Python equivalent bindings. So that's for PySide on Amiga Harmattan, which is Qt4.8 something. So they are just for the Qt core bindings, you have 2.8 megabytes. That's not the Qt core library, that's the Qt core bindings. And obviously, if you want to do some UI, you also have to have the Qt GUI module, which is again 12.5 megabytes for the bindings. Your Qt GUI library itself has something above the same size, I guess. And you then also need QtDD13. So for every Qt module that you want to use, there's going to be a binding module, and it's quite big. On the other hand, PyUGAT, because it's just a QML plugin, and we don't provide bindings for all the Qt classes that you have, it's just very, very small. It's just, I mean, it's really simple, but it does the job. So in terms of usage, you have to do a quick paradigm shift. I would like to say that with PySide and PyQt, what you basically do is the boss is the Python interpreter, and it uses the services of Qt and QML to display the UI. And with PySide, we turn it around to the other side. And here, QML uses Python as a data provider in backend. That means that QML is the boss. Basically, you can do pure QML applications, and then just for things like existing backends, or if you want to use some cool Python module that there's no Qt library for it, you can then use Python and provide that with PySide. So some of the API methods, you're going to see how these are used later on when you do live session. So basically, there's add import path where you just say, okay, I want to have this path and search for Python modules in that folder. You can have a set handler, so you can do even asynchronous events from Python, which I haven't told you yet about. So you can, at some point, even in a different Python thread, you can send events up to QML, and you can handle that. So basically, events are basically a string. For example, updates received could be a string. And then you have a callback, and you do that from QML. So you can say, when updates received is if the event is sent, then I want to have this callback called and do something, for example, show something on the UI. There's a synchronous function that does just evaluate any Python expression. That's quite nice to get started. And because the result is a Q variant, you can have JavaScript arrays or Python lists and everything. It's transformed to the JavaScript equivalent. We will see that later on when we come to the session. And there's import module. So usually you don't just embed all your Python code in QML. What you do is you write everything into a small module, then import that. And because we are asynchronous by default, because importing a module can take a lot of time, again, this is the asynchronous method. You pass in the name of the module and a callback, but only as soon as the callback is called, your imported module is available. And how we handle errors is shown in the next slide. And there's a asynchronous function call method. So pass in a function, arguments if you want, and then a callback. And the callback has one parameter, and that's basically the result of the function. There are two signals on the Python object in QML. There's received with data. That's for all the events that are set from Python without a specific handler set. So if you send some event from Python and it doesn't have a handler set already, this signal will be fired, and you can deal with the data there. And there's an error signal that happens when some error happens inside Python, and you get the traceback as a string there. On the Python side, if you're a Python developer, you might want to use the services of PyUGAT. So there's this module called PyUGAT, which is basically implemented in the QML plugin, so you can't use it from outside. There you have the .send method, which takes a variable list of arguments. That's basically for all the events. So you can even call PyUGAT.send from a different thread, and it will send it up to the QML UI. And there's add_exit, which is nice because I found out when I did one of my applications that when I closed down QML by default, I didn't get any notifications, so I couldn't do stuff like save settings to disk. So basically, on the Python side, you say add_exit and pass some function, and when the QML is closed, when the QML view is closed, this function gets called, so you can still do some cleanups there. And something that has only been added last week is an image provider. So if you know, in C++, you can just subclass, I think it's called QQuickImageProvider or something like that in Qt5. And you can then basically, it has a member function, and you can, from QML, say image source equals this image protocol. And there is the name of the image provider, and then some string. That gets passed to the function, and you can then return some image. And that's something that they've implemented in PySide as well. There's this setImageProvider function, which you can see in the middle of the slide. You pass in some Python callable. It takes two arguments, the image ID, which is basically the thing that you get, that you pass in here on QML, and you get the size, which is, if you know about the QML image element, you probably do if you have done any QML at all, is you can have the source size, width and height, and that gets passed as the size. If it's not defined, it's -1 and -1. It's a tuple in Python. And you basically return the pixel data, which could either be the real pixel data as a byte array, and we'll have some nice demos there later on. You pass, if you're passing pixels, you also have to specify the width and the height and the format, which is basically one of the QImage formats. So you can say it's an ARGB 32-bit image format. But again, we'll come to that later. That's something that you can now do from Python as well. So what does it support at the moment? It supports desktop platforms, obviously. So there's Mac OS X, Linux, and Windows. Although I haven't tested it on Windows, but I assume it works. There's nothing technically preventing it from working. It obviously also works in Sailfish OS, which is the OS that Yola does. And obviously it has the best support. So PyUGAT and Python 3 are already in the main repositories. So it's very, very well integrated there. You can just add the repository and get it, and it's then installed directly on the device, and you don't have to ship any libraries with the application. Because it's cross-platform and it's an open source community project, there's also support for BlackBerry 10. You can take Python 3 from the system because there's actually Python 3 installed there already. But you have to ship Qt 5 and PyUGAT in your application at the moment, which increases the size of the application. And yeah, as soon as they might ship Qt 5, then you only have to ship PyUGAT with your application. There's also support for Android, but because there's no Python installed there, and because there's no Qt 5, you would have to ship Python 3 plus Qt 5 plus PyUGAT in your application, which grows your application to quite some size, especially if it's a small application. If it's a big application, it's probably okay. Okay, so some of the ideas what the future of PyUGAT might bring. One feature request that I had was to embed Python scripts in Qt resources. So right now you have to put your Python scripts onto the file system, and you pass the path, and you can then import it. What would be nice, obviously, is for some application developers to use the Qt resource system and just put all the Python scripts that you want to use inside your single binary, and then load it from there. That should be doable. It's just a matter of time implementing that. For some platforms, it might make sense to do static linking of the lib Python library and of all the Python standard library modules. That again would, for some platforms, help for deployment, but in general, if you're having a desktop platform or any of the platforms that I mentioned before, that's usually not a problem because you can just dynamically link. And because PyUGAT is available on a BSD style license, you can obviously, there's no problem with that. As I mentioned before, CPython is the standard implementation of Python, but there are also different implementations. For example, there's PyPy, which is Python implemented in Python. That's why it's called PyPy. It does have some nice features. For example, a JIT, just-in-time compiler, which might make sense on some in some use cases. And it would be nice to try to integrate PyPy with PyUGAT. So that's also something that you right now, as far as I know, can't do with the other bindings. But I'm not sure about that. And because right now we just pass simple values between QML and Python, what would also be nice is wrapping Python objects or references to these Python objects as QML JavaScript values so that they can actually return a Python object to your QML environment and then call functions on that and wrap that. But I'm not sure. I mean, it might make sense from a syntactic point of view. I'm not sure if it's a good idea from a performance point of view, because you might want to structure your code in that way that's really performant if you're doing mobile development. Okay. So now it's time for snakes on a boat, which means live coding, and hopefully this works. Okay, so let's first check the font size. Can everybody in the back see is it big enough, or should we increase the font size a bit? It's good? Bigger? Smaller? Different color? Okay. So let's first, before we do some examples, let's just go into the code a bit, just so that you get an idea of how it's structured. So it's really it's really quite small, and it's really quite simple. You can probably read it in the afternoon. What the basic heart of all the project is converting between a Python object and a Qt object, which in our case is QVariant. And that basically happens in the converter. Are the colors okay? I think so basically it's made in such a way that you could theoretically also take another scripting language as long as it has a similar object model. So you have lists, you have dictionaries, and you have all the primitive data types, strings, floats, booleans, and so And that's what you have to implement. You have to create a class that can build a list out of some other values for that specific object type. You have to build a dict, and you have to iterate over a list and iterate over a dict. For those of you who don't know Python, list is basically an array in JavaScript terms, and dict is basically a JavaScript object, or in Q terms, it's a map. And then you have the converter. So these are the types that we support. So you can't just pass any arbitrary objects. You can pass integers, floating point numbers, booleans, strings, lists, and dictionaries. And that's usually all you want to do anyway. So if you, for example, have a list model with some things, you would pass a list of dictionaries, and that would be okay. So basically, the converter then has to implement these functions. So, for example, my Python object converter has to know how to what kind of type an object, a Python object is. It has to know how to convert it to an integer, if it's an integer, how to convert it into floating point, and so on. Now, in terms of Python, the PyObject converter looks like this. I can build a list for a Python object. So I just call the Python API functions like that. So that's wrapped here. And I can just append stuff and get the value from the list. Then I do the same thing for a dictionary. So that's quite boring. But just to get an idea how you could even extend it and add your custom classes. Then there's list iterator, which works actually for Python tuples. So you can also pass Python tuples in there, which just, if you could see it as immutable list, although that's not totally correct. And yeah, then you basically only have to later on do stuff like you get the type. That's Python API code. You don't want to deal with that. And you also do the reverse. So, oops. Okay. So I'm jumping around a bit here, but just to give you an overview. So basically, you just wrap all the functions for that specific. So that's the Python object model. And of course, the same thing exists for QVariant. And if you're a Qt developer, that's probably very familiar to you. So you just have a QVariant list for the lists, a list of objects. You have a QMap with QString and QVariant. So one restriction of that also, it means that your dictionaries can only have strings as keys, but that's usually okay because as far as I know in JavaScript, you don't really want to have any other types there as well. So that's one of the restrictions. You could fix that, but it's not implemented right now. Okay. So as I said, PyUGAT is implemented as a QML plugin. So let's jump into the examples. A very simple example here is this one. Basically, that's Qt5, Qt-Quick 2.0. You just import Qt-Quick 2.0 as usual. And the PyUGAT import is called io.php.pyugat 1.0. And the only thing that it provides is this Python object here. And it provides all the API functions that we discussed. So what you usually do is, when it starts up, you do some component uncompleted stuff, which is where you load your Python modules. And for example, you want to use the OS module from Python. So you do in that's in the context of the Python object. So obviously, I mean, you probably know QML. So if you're doing from somewhere else, for example here, you would do python.import module like this. So we do an import module. We pass in the name of the module and then a function that gets called as soon as the module is imported. That means that here in this line, as soon as the call is finished, you will the JavaScript context will continue on this line, and later on the module will import it, and this code will be called. Then you have to do asynchronous function calls. For example, I want to list the current directory, so I call os.list here. This is the parameter. So if your function, for example, has one integer parameter and one string parameter, it would look like this. Again, it's not really wrapped completely with the JavaScript environment, but still works nicely, and it doesn't. I mean, it's obvious to the user then what really happens. And then you have a function that gets called when the function finished. So again, this call doesn't block It just sends that request to the Python interpreter. And when the function returns, the result is the first parameter in the function that you pass in there. So you have the directory listing, and you can, for example, set the model of a list view that you have to that result, which might be a list of strings, because OS lister returns a list of strings. Let's just so what I'm basically doing here is import OS. That's the Python interpreter. So I do import OS. I call os.lister, and it gives you a directory listing. As I said, I wanted to make sure that the synchronous API is really, really hard to use, so that you use the synchronous API. So all the synchronous functions have _sync in there. So you can obviously also do synchronous calls, but avoid these, because these really block the UI. And if there's some other thread running with Python code, it might be that because of the global interpreter lock, even if it's a very simple call, it might take some time, because the global interpreter lock has to be acquired first. Then a call can be made, and then it's released again. So don't do that. But if you really have to do, or if there's some legacy code that needs it, you can use it. But really avoid it. Then you can obviously also import the PySide module and so on. And if you have some error handling, that's happening in the onError signal handler. So the signal is called error. The handler in QML is onError, and you get the trace back as a string, and can deal with that there. And as I said, there's a way to do events from QML that can happen in any thread you want. It's thread safe, and you call pyotherSide.send from Python, and you pass in a variable list of arguments, and this is then, if you haven't set up a handler, it's then received by onReceived. So start that. Okay, so what happened here? We have the QML view, and it has a list view, and this list view now has 2 items, which is obviously the files in this directory that we are in right now. On the console, you can see that there's a got message from Python, so that's the handler that gets called. I tried to import the module that's called this module does not exist. Hopefully, if it does exist, it would not throw the error. So that's how you do error handling on the console, but you can obviously show it in the UI as well. If you're evaluating something and you get the syntax wrong, that's also displayed on the error signal. And when as you see, these synchronous imports happen before the OS model is even imported, because we do it in an asynchronous way. So you have to take care of, make sure that you don't assume that it is already available. Only when this function gets called, it's imported. And as soon as it's available, you can do something with it. For example, you can show all the files in slash in the root directory, or you can also then get the direct listing of the current directory and feed that directly into QML. So there you have a Python function that returns a list of strings, and you can very easily push it to your QML list view and show it there. Obviously, you might not want to do directory listings, but just shows how easy it is to integrate. So basically, what you need to do then is import this module, io.php.pythonside, create a Python component here. And then you can, for example, import the module asynchronously and call list here or any other function you want, and it takes care of translating the results for you. Okay, so that's that. Now let's just do a quick example from scratch. So we do import quick 2.0. We do import i.php. So that's just importing. Then we just do I don't know, a rectangle, for example. And then you create your Python component. And now, for example, you want to print the squares from 0 to 9 or something like that, because obviously that's fun. Say when this component gets created, which is at that time you can actually use the Python interpreter. you can say evaluate, which is again a function on this Python object. So assume that if it's called py, you would say py.evaluate. But in this context, you can also leave out the py. Yeah. And here you pass a string. That's basically any Python expression. So what you want to do is we want to join a list of items with a comma. Because we're joining strings, we have to convert it into a string. X squared. And now we want to do that for all the numbers from 0 to 9. And that's how you do it in Python. So the nice thing is you can do stuff like list comprehensions, which you might know from functional programming language already in Python. It will be supported at some point in JavaScript, but as far as I know, you can't do it in QML right now. Okay. So let's just log the output here, what we get. And so we don't display anything yet, but as you see here on the console, we already print all those squares from 0 to 9. Now you can integrate that obviously with your UI. I mean, you probably know how to do that at that point. You would just say, for example, just create a text element, and then you can just say equals py-evaluate. And that's something that you now do like this. But because QML is declarative, you probably don't want to do it like this. You just want to say the text is this one. Remove that. And so you get just the stuff from Python directly in QML. This you can do because at this point, the Python object is already initialized. If you're doing imports, obviously it's not that, it's a bit difficult. You might have to set the bindings dynamically. Okay, so pretty basic examples. Let's do something else. Image loader. One thing you might want to do is create a Python module that draws the Mandelbrot set. Usually you don't really want to do that. It's just for demo purposes because Python, doing many calculations there in CPython is quite slow. You want to do that in C++ or ideally as a fragment shader on the GPU. But here, just for the sake of argument that you can do per pixel image generation from Python and pass that back to QML, we show how to do it. So basically just create some colors. There's white, there's black, and some random colors in between using for coloring our Mandelbrot figure. There's the function which basically calculates which color is used for some coordinate. And then there's this image provider that we can use from QML. So that's similar to the C++ QQuick image provider. It gets two parameters, the image ID and the requested size. And if you don't pass in the requested size with source size width and source size height, it's by default -1 and -1. Then you can set some default size. In the QML file that we're going to see later, I just pass in the URL like this, image column / Python, and then the floating point values of the window that we want to have rendered. So that's just floating point values of the window, xmin, xmax, and ymin and ymax. And so we just split it up in Python and then get basically a list of floats. Then we have the x range and y range. That's just transforming the coordinates from QML to a string and back, because that's how the image provider works. And then we just calculate all the pixels, and we go through the width and the height, calculate every pixel by looking up the color, and then return these pixels as a byte array object. And we know the width and the height. And you also have, because it's just a byte array, and it's just an array of pixels, you also have to specify which format this blob of data has. And in our case, it's ARGB32, which means there's one alpha byte, 1 byte for red, and 1 byte for green, and 1 for blue. And that's basically the cost as you above. And how this works is you then, in the Python code, have to set the image provider, which is again this callable that's above. And this sets the image provider for the image colon / Python / something URLs in QML. So as soon as you just import that module, it registers, and then you can just use it. So let's look at the QML. Again, we import io.php.PySide. That's just some calculations done for zooming and panning around. And scroll down a little. So that's just some UI stuff. You can actually import directly from a directory relative to the QML file. Just resolve the current directory, strip away the file colon // and then you can just import the Mandelbrot module, which is mandelbrot.py in the same directory. And when it's imported, because when this component uncompleted finishes, the module is not yet imported, which is great because you can already see the UI, but then you cannot use the image provider. And then we call the update image timer, and that will take care of calling the image provider. So that's something that you have to be aware of. If you do it in C++ and already expose the image provider before you show the view, you could directly use the image colon / URL. In Python, that's not possible, but we also don't want to make it possible, because in that way you are basically forced to make sure that your code is asynchronous, that your UI shows up very quickly, and just after everything is loaded, you then continue with processing. An update image timer, it's basically when the timer runs out, the image source is set to this URL, and we put in here all the coordinates for the window that we are going to render. So let's try that out. Okay, so now that's the Mandelbrot set rendered with random colors, and the rendering of that is happening in Python in a really naive way, but it's not that slow. Again, you don't really want to do that in production code. You want to render that in a fragment shader on the GPU. But it shows you what's possible to do with the image provider support there. So you can drag around, zoom in, and every time something changes, the timer starts, and it calls back into Python. Python then renders this small image as pixel by pixel, gives this blob to QImage, and QImage then gives it back to QML. Of course, if you increase the size of the window, there's more pixels to be rendered, so it's a bit slower, but it still works nicely, given the fact that you actually do that in a scripting language like Python for every pixel. And that's also one of the areas where it might be nice to have support for PyPy, because then the JIT would take care of making these things faster. So you can do per pixel rendering in Python, or you can also just pass in a string. Oops. I mean, basically, what you can also do, instead of decoding your image, instead of decoding your image directly into pixels and passing that, you can also just take, for example, the bytes of a PNG file or JPEG file that you, for example, get from some database, and pass that back. And there you have to specify the special format that's called data, which is not really a pixel format, but it just tells PyUGAT that interpret that as data and use QImage.load for loading that. But obviously you don't want to fall back to that if you are generating the pixels by yourself, because that would require that you first generate your pixels, then encode it in, for example, PNG, and on the Qt side decode it again. So that might not be too fast, but if your data is already in PNG format or JPEG format, this is what you would use. So here I have just a small image encoded in Python directly, so it's not like somewhere in the file system. And if I start it, I get this image loaded where it's already encoded in PNG in the QML scene. Okay. So on the slide I said snakes on a boat. So we might also want to do all of that on Sailfish. So what I have here is the Sailfish OS emulator running. That's basically an x86 emulator of Sailfish OS. And because Python, you don't have to compile stuff, what we are going to do is we SSH into the emulator, do some Python coding there, and then show this in the emulator, which is quite nice. And on a real device, you can obviously also do that. You can either open up the terminal, do some Python coding there, and show it, or you can SSH into your device, code there, and directly run it without having to compile anything and without having to deploy it to the device. So I log into my emulator here. So that's basically an SSH session to this virtual machine running here. Let's go into examples. For example, there's a simple example that we've seen before. That's without any Sailfish theming. So if you just run a pure QML application there, just looks like this. That's a root directory of the emulator. So it just works like that. There's no compiling involved. You just copy the stuff over and can run it directly with QML scene via SSH from the emulator. What I also want to show you is one of my applications that I'm working on, and that's actually a mobile application that I've been doing for some years, and previously I've been using PySide for that, but the UI was kind of slow, and now I'm trying to focus on making it really fast, really responsive, and not blocking anywhere, even if your Python code is doing lots of processing. So I just use QML scene. So as you can see here, there's really no Python code involved at all at the startup. Just when the view is up, it loads the Python module and takes care of loading any data in there. I mean, that's an x86 emulator, so it's obviously quite fast, but even on ARM devices, on real devices, startup time is quite fast. So again, start it up, and it's here. That's all in QML. That's actually pure QML, just for demoing cross-platform stuff. So as what you see here is not the real Sailfish UI. It's just a custom QML, pure QML QtQuick 2.0 UI, just for testing. And all the data that's loaded from that they see here, the images, the episodes, names, titles, all that is provided by a Python backend. So when you open a view in PySide, what usually happens is that when you tap on something, the UI would call back to the Python code, and Python code would just read the data there. And so when you press it, it would wait a bit, 1 second, 2 seconds, and then it will show up. Here you can actually see that the animation is running while data is loading, if there's lots and lots of data. So that's quite nice. Yeah. So let's try to do the same thing in the Sailfish emulator that I did previously. Go ahead and create a very small example from scratch, and try to use some Python modules that we have here. So again, we start with QML file. It might be boring to see how we're just importing stuff, but that's just so that you that I want to show that you can really do that without any IDE, without any compiler, just directly on the device. Because we are now on the Sailfish emulator, we also want to use Sailfish components. They are called sailfish.silica. And instead of using a rectangle or something, we're now going to use an application window. And the application window has an initial page, which is basically the page that you see at the beginning as a property. And so application window is coming from Sailfish Silica, and there's also another component called page, which is just a page, obviously. So one page of screen, and you can have multiple pages and stack them on top of each other. And there I want to have a label, which is basically the same thing as a QML text element, but it has some Sailfish specific theming. So label is also coming from sailfish.silica. And what we want to do here is, for example, hello world, and just run that to see how it looks. Okay, so we have selfish application running on the device emulator, no compiling involved, no deployment involved, and that's just pure QML. There's no Python going on here at the moment, but you can do that, and I think it's quite nice to be able to quickly prototype something without having to deploy stuff around. Now you can just import Python modules there. So what we want to have is a Python component, which is taken from this import here. And how many minutes do we have? 5. Okay, plus some questions then. Okay. So yeah, let's say it's called Py. And what we want to do is not print hello world, but encode that with ROT13 because we are secret. We do secret things, and we want to use ROT13 as the encoding for our secret message. And Python obviously provides that. You don't have to code that in JavaScript, for example. So what we do here is we need to import something from Python. The module is called codex. And when the module is imported, you can then so like this. You can then call, or you can do codex.getEncoder for ROT13, which is our very secret encoding, and that returns a callable object. So they are passing hello world. And it actually returns 2 values, the encoded string and the length. So I get the first one of these. Just to show you what it basically does on the Python shell, because otherwise it might be confusing. I do an import codex, get the encoder, which gives me some encoder object. And then on this object, I pass in hello world, which returns 2 values, the secret encoded string and some length. And from this, I take the first value. So I just basically pass in hello world, tell Python, please encode that in ROT13, and get the first element of the tuple that's returned. So that's what we do here. And then we say this is and now you have ROT13 encoded secret messages in QML on Sailfish OS using Python. Okay, so any questions so far? Yeah, there's one.
Yeah. In the Mandelbrot set that you show that we should use some production code, we should use a fragment shader to render or display the image that you created. But question, does QML support I mean a real programmable shader like CUDA or OpenCL? Or you're talking about just GLSCL to change a little bit?
Yeah, there are. I mean, that's not related to Python, but there what I meant is that you can use, for example, the shader effect item, or how it's called, and then use a fragment shader, a GLSL fragment shader, to calculate the pixel values there.
Okay, thanks.
Yep.
One moment. Have you used, for example, larger libraries like Python NLP via this library? And how is
natural language processing?
Yes.
I personally haven't used it, but there's nothing preventing you from using it. Does it have is it a pure Python module, or does it?
I don't exactly know, but that is what I would like to use this integration for. I have some people who are working on it. Is there anyone here who would have used QML and Python NLP? No.
I mean, basically, there's nothing preventing you from doing it. What might be a problem is if the Python module that you want to use, for example, the NLP module, doesn't support Python 3, then you might have to use the Python 2 version of PyUGAT.
Okay, fine.
But in general, you can use any Python module. I even have another example that I might show, which is using matplotlib. So that's something that's used in scientific computing. And oops, obviously I want to use the QML file here. So what you can do here is matplotlib is a Python library for plotting graphs and stuff like that, plotting data, and that's actually using NumPy and some other scientific models. So if you're into scientific computing and you do this kind of stuff, it's very easy to reuse that. And matplotlib basically renders into an image, and we use the image provider function to do these kinds of things. So of course that's just an image, but I have here just a text field above. If you probably don't see it in the back, in the top left, there's a text field that you can edit. And now if I start editing this, the graph changes, because I'm just taking the string, passing it to the image provider, and it renders the graph. So what I can do is now say 1, 2, 3, 4, 5. And then I do a semicolon. That's just how I implemented it in the Python backend. And then I go 9, 8, 7, 6, 5, 4, 8, 2, 8, 2, 8, 2, whatever. So you can do these kinds of things. You can reuse all the existing Python libraries, and you might be able to do stuff like plotting that. It might not be the most efficient way because it's actually rendering it to an image and passing that back, but it's quite fast. And because it's an image, you can get all the advantages of the fast Singular, because it doesn't re-render it. It's just once it's rendered once, it's just an image, and you can deal with just any other image in Python. So yes, you can usually use all the existing modules depending on how you want to integrate that. And the same thing with different renderers. So matplotlib can do all kinds of things. You can even have 3D graphs and all kinds of things. And one of the nice things is, if you know XKCD, there are all these diagrams, and matplotlib actually has some functions for doing graphs that are styled like this. So that's again the same example, but using one of the examples from matplotlib. So again, you can do very cool XKCD graphs by using any Python library, in that case matplotlib, and using this in your QML code. Obviously you have to build these Python modules, but for example on a desktop it's no problem. On mobile you would have to compile these modules and ship it with your with the application, obviously. But that's something that's definitely